Here we have example 1, and the directions say simplify each of the following multiplications using properties of exponents. Leave answers as powers. So they want you to go ahead and leave the answers as a power. Now that is, unless something happens to turn out to be a 0 power, and then we always go ahead and write 1 instead. So go ahead, and you know the drill. I want you to pause the tape and see if you can get these, and then push play, and we'll come back together and see what your answers are. All right, so go ahead and push pause now. Okay, so hopefully you did that, and now you're back, and we're going to check our answers. Okay, so with our first problem here says 5 to the 7th times 5 to the 12th. So again, we're multiplying like bases, so our rule says that we need to add those exponents. So 7 plus 12 would give us 19, so this would equal 5 to the 19th power. So I hope you got that. Now our next one. Our next one says 5 to the 12th divided by 5 to the 7th. Well, again, we are dividing like bases, and our rule says now that we're supposed to subtract the exponents. So 12 minus 7 is 5, so this should equal 5 to the 5th power. Now what about part C? Part C says 5 to the 5th divided by 5 to the 5th. So again, I mean, you could look at this several different ways, but we're dividing like bases, so we're supposed to subtract the exponents. So that's going to be 5 minus 5, which is 0, and anything to the 0 power is 1. Okay, on the next page we have a few more here. So we have 5 squared raised to the 9th power. So whenever we have a power raised to another power, the rule says that we're supposed to multiply those. So this is going to be 5 to the 2 times 9 power. Well, 2 times 9 would be 18, so this is 5 to the 18th power. Okay. In the next one, here we have xy as a quantity, multiplication, being squared. So I said that most of the time whenever you see these, it's going to be in this form. It's almost as if we are distributing that squared throughout those parentheses. So this will turn out to be x squared y squared. Now I could have shown you, and I probably should have, the long way around about this so that you know why it's happening. If I have xy squared, that's the same thing as saying xy times xy. Now all of this is multiplication, so we really don't need the parentheses. We could write it as x times y times x times y. And then because multiplication is commutative, you can multiply in any order that you want to, and it doesn't change it. So I could put the x's together and the y's together by saying x times y times y. And then x times x can be written more compactly as x squared, and y times y can be written more compactly as y squared. So that's what's really going on there. And then finally, we have one that says FG as a product raised to the 8th divided by FG as a product raised to the 2nd power. So even though these are not just a single letter or a single number, then the concept is still the same. We still have the exact same bases. So our rule says that we're supposed to subtract those exponents. So if I do that, I get FG raised to the 8 minus 2, which is the 6th power. And now then I still have a product raised to a power. So It's almost like distributing that power throughout that product. And I could write it in its most simplest form, oops, as f to the sixth g to the sixth.